So let's do a spontaneous video on mathematics. So fundamentally, I'm a mathematician with a little bit of interest in spirituality. And the two are closely linked. Spirituality is basically in a very deep sense, it is the ontology of basic mathematical entities. If you understand the existential importance of the concepts of zero, one, two, and infinity, that is all the spirituality that you need to know. So we'll talk about a little bit about the pre-axiomatic and post-axiomatic levels of mathematics. So in the pre-axiomatic level of mathematics, where we study the existential nature of fundamental mathematical entities like 0, 1, 2, and infinity. The pre-axiomatic level is basically mysticism, metaphysics, and spirituality and philosophy. It's in the realm where logic cannot penetrate. But the post-axiomatic level of mathematics is all the practical mathematics that we learn in our education. So the fundamental areas of mathematics that any serious student of mathematics must pursue are algebra, analysis, and topology. And there are further subdivisions and interconnections and intricate connections between these three areas of mathematics. Each one is needed for the other two. You need algebra for analysis and topology, you need topology for algebra and analysis, and you need algebra for analysis and topology. So I've been teaching mathematics for the last approximately 3 years at an engineering R&D company. So the topics I've thus far covered are complex analysis, real analysis, linear algebra, algebraic topology, functional analysis, symmetry, measure theory. So real analysis is basically the rigorous logical foundation of the field of calculus, which is the study of change. Calculus is of fundamental importance in the study of physics and in engineering. Mathematics in general is indispensable in the marketplace, in the business world, in sports, in physics, in engineering, in medicine as well, because you need to measure things all the time. So we can define mathematics as a study of structure, order, measure, change, space, numbers. So the 7 topics that I've thus far taught at Honorix are only a small subset of the potential topics that one can explore in mathematics. Some others are differential geometry, algebraic geometry, numerical analysis, combinatorics, discrete math, differential topology, harmonic analysis, among others, partial differential equations, analytic number theory. So mathematics is basically the language which describes natural phenomena, and it has proved to be, as Eugene Wigner puts it, unreasonably effective in providing a framework with which to describe the phenomena observed in nature. Newton discovered the law of gravitation, which can be expressed as a differential equation, and that differential equation can be solved to prove that the orbits of planets are approximately elliptical, to a very good approximation elliptical. It can be proved that a chain hung between a pair of points which are at the same level takes the shape of something called a catenary, which is a mathematically precise form. It can be proved that any projectile shot at an angle, fixed angle to the horizontal, travels the trajectory of a parabola through space. Then comets often follow hyperbolic paths. Comets which approach stars follow hyperbolic paths. The Pringles chip is a hyperbolic paraboloid, which is a surface which can be expressed as a polynomial of degree 2. So mathematics is basically everywhere. It's ubiquitous. It's an essential ingredient in building and sustaining computers. It is indispensable for practical functioning because, but that is at the most fundamental level. To count money and to count objects, which just requires addition, subtraction, multiplication, and division, and maybe a little bit of graphs. Graphs are required much more in the world of business. The graphs y equal to f of x, which we draw of functions. The more abstruse and abstract and involved and esoteric levels of maths are necessary when you go deeper into the study of science. Often, pure maths is considered useless by some people, but that is an inaccurate assessment of the situation because often things which were useless have proved to be very useful in the future. Things that seemed to be useless at time t1 turned out to be useful at time t2 greater than t1. For example, mathematicians had worked out the theory of Riemannian manifolds in the field of differential geometry much before Einstein came along and found that it can be applied to describe gravitation in the theory of general relativity. Group theory had al- Group theorists had already studied symmetry in great detail before chemists came along and saw the applicability of group theory to the description of molecular structure. The theory of Hilbert spaces was well established before quantum mechanics came along, and Hilbert spaces turned out to be a central tool in the study of quantum mechanics, which is the study of subatomic phenomena. In engineering, mathematics is indispensable. You need to measure things all the time. You need to understand interrelationships between quantities all the time in engineering. The study of interrelationships between quantities is one of the aspects of mathematics. So these are all the post-axiomatic considerations in this field of mathematics. Practical mathematics, basically. But there is the pre-axiomatic level in which we study the fundamental existential relevance of basic mathematical concepts like 0 and 1. So the most basic set of axioms in mathematics are Euclid's axioms in geometry and Peano's axioms for the existence of the natural numbers. So an axiom is basically a statement that has been assumed without proof because it is reasonable and because it cannot be proven. So the first axiom in mathematics is the existence of one. So we enter a very deep question here. What is one? Or in philosophical jargon or language, what is the ontological status of one? So one is basically a property of every apparently existent object. There's one guitar over, one black guitar over there, one green work of art on the wall, one shirt that I'm wearing. Every object has the property of oneness. It is one of any object that is perceived, one copy of any object that is perceived. So we can just go on and on about mathematics. We'll discuss more mathematics in future videos.